Welcome back. In this video, we'll take a closer look at Google Cloud load balancing, covering its architecture, configuration, and important points to keep in mind. Imagine you own a popular website and thousands of users are trying to access it at the same time. If all those requests go to a single server, that server can become overloaded, slow down, even crash. That's where a load balancer comes in. A load balancer is a service that sits between users and your application servers. Its job is to intelligently distribute incoming traffic across the multiple backend servers so that no single server became overwhelmed. Think of it like a traffic police officer at a busy intersection. Instead of sending all vehicles down one road, it directs traffic across multiple roads to keep everything moving smoothly. Load balancers improve application availability, scalability, and performance. If one server becomes unhealthy or goes offline, the load balancer automatically stops sending traffic to that server and redirects user to the healthy server. This helps ensure that users can continue accessing the application without interruption. In cloud platforms like Google Cloud, load balancers can also route users to the closest available region, reduce latency, provide SSL termination, and protect application from traffic spikes. As we go through the setup, we'll encounter a few key components that form the core of a load balancer configuration: host rules, path rules, backend services, and backends. Understanding how these components work together is essential for routing traffic correctly to your application. Understanding how these components work together is essential for your routing traffic correctly to your applications. Host rule: determine which domain name or host the request is intended for. Path rule: this determines where to send traffic based on the URL path. Backend services: a logical configuration that defines how traffic should be distributed and managed for a group of backends. Backend: the actual resources serving the application, such as VM instances, instance groups, or Kubernetes servers. Now, let's understand what actually happens behind the scenes when a user accesses an application through a Google Cloud load balancer. In this example, a user opens their browser and enters the URL www.example.com. Step 1. DNS resolution. The first step is DNS resolution. The user's machine queries DNS to find the IP address associated with the example.com. DNS responds with the IP address associated with the Google Cloud load balancer, which is in this example is 34.120.50.100. At this point, the user still does not know anything about the backend servers. The only visible endpoint is the load balancer's IP address. Step 2. TCP connection to the load balancer. Next, the browser establishes a TCP connection with the load balancer by performing TCP three-way handshake. This connection is created between the client and the load balancer, not directly with the backend virtual machines. Step 3. Sending the HTTP request. Once the connection is established, the browser sends an HTTP request. In our example, the request is get/products. Header contains www.example.com. These two pieces of information, the host header and the URL path, are extremely important because they are used by the load balancer's routing rules. Step 4. Host rule evaluation. The load balancer first evaluates the host rule. The host rule examines the host name, which is www.example.com, and determines which routing configuration should handle this request. This allows a single load balancer to serve multiple domains. Step 5. Path rule evaluation. After the host rule matches, the load balancer evaluates the path rule. Since the request path is /products, the load balancer checks its configuration path-based routing rules to determine which backend service should process this request. For example, /products could go to one backend service while /API could go to another. Step 6. Backend service selection. Once the appropriate routing rule is identified, the load balancer selects the corresponding backend service. The backend service contains configuration such as health check, session affinity setting, and the list of backend resources that can serve the traffic. Step 7. Backend VM selection. The backend service then choose the healthy backend instance from the managed instance group. In this example, the load balancer selects VM2 with internal IP address 10.1.0.6. This selection can be based on Google's load balancing algorithms and the health status of the instance. Step 8. New connection to the backend. Notice something important here. The load balancer creates a separate connection to the backend VM. This means the client to load balancer connection and the load balancer to backend connection are two different connections. The backend VM never communicates directly to the internet client. Step 9. Backend generates the response. VM2 processes the request, generates the page content, and sends the response back to the load balancer. Step 10. Response returned to the user. Finally, the load balancer forwards the response to client using existing client connection. From the user's perspective, it appears as though they are communicating with a single server, while the reality, the load balancer is intelligently routing requests to multiple backend instances. The key takeaway. The most important thing to remember is the routing decision flow: host rule, path rule, backend service, healthy backend VM. This sequence is core how Google Cloud Application load balancers route traffic effectively and reliably. Thanks for watching. This concludes part 1 of our Google Cloud Load Balancer series. In part 2, we will dive into different load balancer types, understand when to use each one of them, and cover other important topics that every GCP practitioner should know.